Hello everybody, welcome to today's video. Today we are going to see about smart grid technology as a renewable resource. This is a chemistry case study. So today's agenda is introduction, methodology, solution, validation and summary. Introduction. A smart grid is an electricity network based on digital technology that is used to supply electricity to consumers via two-way digital communication. This system allows for monitoring, analysis, control and communication within the supply chain to help improve efficiency, reduce the energy consumption and cost, and maximize the transparency and reliability of the energy supply chain. The term smart grid was coined by Andres E. Carvalho on April 24, 2007 at an IDC Energy Conference in Chicago. Definition. Smart grid is an integration of an electric power system, communication network, advanced sensing, metering, measurement infrastructure, complete decision support, and human interface software and hardware to monitor, control, and manage the creation, distribution, and storage consumption of energy. Methodology. The first step is to map all physical components from the uses of to the component layer. Example of component layers are controller, computer, the grid, EVs and transformers. These components are derived from actors' information, as actors can be type of devices, application, person and organizations. The next step is to map the business layer, the domains and the zones covered by the components compose an area. The business objectives, economy, and regulatory constraints included in this area influence the mapped use case. These objectives and constraints are located in the business layer and need to be taken into account as non-functional requirements for implementation. And these steps go on. Solutions. As with any networked environment, security must be a key consideration of an IoT-based renewable energy installations. Given the criticality of the services they deliver, any compromise to the integrity of IoT renewable energy grids could be disastrous, potentially causing power shortages and even blackouts across internet power grids. A variety of traditional security techniques may be applied to help protect renewable energy grids, including the time-tested technology such as VPNs. Encryption may also be employed, but given the volume of data and the velocity at which it transfers the IoT grids, some familiar implementation of encryption, particularly software-based encryption, just can't keep up. A more viable alternative may be hardware-based encryption. Validation. Electricity generation from wind power and other renewable energy sources is increasing, and their variability introduces new challenges to the power system. The emergence of smart grid technology in these recent years has been a paradigm shift in redefining electrical system of the future, in which the controlled response of the demand side is used to balance the future actions and the intermediations from the generation side. This paper represents a modeling framework for an integrated electricity system where loads become an additional resource. The agent-based model represents a smart grid power system integrating generators, transmission, distribution, loads and market. The model incorporates generator and load controllers, allowing suppliers and demanders to bid into real-time pricing RTP electricity market. Summary. Smart grid technologies are deployed across the state at such varying rates. The ARRA funding gave such a strong incentives for adaptation and deployment, with its impact in improved efficiency, consumer involvement and reliability. Newly developed smart technologies and control systems providing the information that advances the business progress and utility operations. Disruptive Disruptive challenges on the horizon are evident with the amount of disruptive and renewable increasing, creating the need for sophisticated intelligent grid. Thank you.